Okay, so a question about collisions. So the thing that we need to remember about looking for points where things collide is that these two things should be equal at the point of collision. They should have the same I component, the same J component, and the same K component. So first thing I'm going to do is I'm going to search for possible solutions of the I part. So they should be equal. Okay, so now I can rearrange and try and solve for when t will make these two things equal. So if I take this over, it'll change to plus and I'll end up with 2t squared. If I take this over, it'll change to minus and I'll end up with minus 6t is equal to 0. So either I could chuck it in my calculator from this point and use solve n. I don't have to though, this is a pretty standard one. If I factorise the 2 out of both of these and take it to the other side, divide it by 2, it's still equal to 0. Which would give me t squared minus 3t. Then I can factorise a t out. Using null factor rule, I can see that t is going to be equal to 0 in that first part and positive 3 in the second part. Now I'm going to exploit that these should be the same for the second part. So I'm going to first let t equal 0 in this one. So Rp for the J component is going to be equal to, when t equals 0, that's 0, plus 3, so 3. We're going to let t equal 0 in the second part, Rqj. So when it's 0, that's 0, so it's equal to 0. So then t cannot be equal to 0. Now we can test out 3. So we're going to let t equal 3 in Pj. So that's going to be equal to 3 squared is 9, 18, minus 3 is 15, plus 3 is 18. Now if I do that in the second part, we're going to let t equal 3 in Rqj. So 3 times 3 is 9. Plus 3 squared is also 9. 9 plus 9 is 18. So that is the correct one. T must be equal to 3.